Hello. In section 4.2, we'll be talking about network mining. So we're going to be using this library that's called NetworkX. So please go ahead and conda install this, right? The usual way you can just do conda install right in your terminal. But network is actually pretty important in a way that a lot of the data is actually saved in the way that should be kept in a network. For instance, like your Facebook, right? Think about Facebook data, LinkedIn data, all these like social media data have, it's best to represent it, right? They're best to be represented and saved in a network format. So that's why it is pretty important to understand how it works and how to make it work in Python. So network. Okay, so let's say once we import this like network X and then call it maybe an X, right? So we're gonna actually create a directed graph. So directed means like there's a direction, right, from me to you, right? There's that direction. So you can say an X, right? It has like, if you just do an X and then dot and then tab it, and you know, see all these functions that you can use, right? So what if I say, so if you do graph, that means it's not going to be it's not directed, right? So di graph, it's directed, and then we can actually call it as like G, right? So this is our graph, and then we can keep adding things, right? Adding nodes. Remember, a graph has nodes, right? Edges. So edges are connecting nodes. So we are first going to add nodes. So U is one node, we call it U, and mom is another node, right? And Alice is another node, and fiance is another node, right? So we're gonna have 4 nodes, and then G dot add edges from, right? Like from you to mom, from you to fiance, from mom to you. All these are like edges. You can add edges, right? So you can see G dot add edges. If you just you can actually do it this way, or just add edges if it's not directed, right? So if you don't want the edges to be, or if your network is not directed, then you can just do add edges without this from, right? So then we can actually draw this graph, right? So we're passing G, our graph, right, with all these nodes and then edges added, and then the way that we want to present it is really circular layout. So there are many layouts in networks or NetworkX. Then you can actually pick one, right? I picked circular in here, so it's kind of like a circle, right? And then this is just a size, right? The size of the node, and this is just the color, right? And then this is a node color, and then this is right. So then we can pretty much print it, right, like this. So okay, let's see. Okay, so you can see you and Alice, mom, fiance, and then here, right, when you have two passes or 2 edges that's coming from Alice to mom and mom to Alice, then you have all these like 2, I don't know if you can see it in here, right? So that this means that it's connected in 2 ways, but only if this is like, there's only one pass from Aunt Alice to you, then you can only see it like this, right? Because that's how we define it. So there's no you from you to Alice. It's all just from Alice to you, right? So, because, I mean, if we add it like one more, for instance, from, say, you, and then, Aunt Alice. Then if we just do it this way, then you can see that it's going to be, see, it's added, right? So this means from Aunt Alice to you, you to Alice, right? Okay, great. So, and then what we can do next is, there's another layout, right? Spring layout is like this. It's opposed like circular. There's more like a circle, right? But this is like a spring, right? It's pretty much like it tells you the nodes relations, right? Like the layout, right? So just many, there are many layouts that you can actually use to represent, right? So now let's look at explore some of the functions that we can actually use from networks, right? So networks, like G is our, if we just print out G, it's like, it says networks class, right? It's coming from a class, and then this is our class object, right? And then diagram, and then it says, right, it's a directional graph. And then what we can do is okay, what if I want to know the number, right? Because we know, I mean, we added the nodes, but what if we want to know the number of nodes, right? So number of nodes is a function, so we have to do it. So we have 4, right? As we design this graph. And then we can do number of edges, right? The same way, right? G dot number of edges. You can actually see in here, right? So we have 7 number, edges. And then, and you can actually look at for one node, right? How many edges are coming in, how many edges are actually going out, right? So you can actually look at the relationships and also just print out the nodes like this. So if you just do nodes, right? Because this will give you like the name of the nodes, and then same thing for edges, right? So you can actually see you fiance, you and Alice, and then so forth, right? So then the next one is pretty interesting. It's called betweenness centrality, right? And then betweenness centrality is pretty much in here, like it says, compute the shortest path betweenness centrality for nodes. So later we're gonna actually talk about like shortest path, right? So in a network, like, so for me to get from say for say Alice, right? Because Aunt Alice is not connected to fiance or my fiance or your fiance, so therefore like it has to go through you, right? So this is like the shortest path going, for Aunt Alice to reach out to fiance, right? So therefore I have to, for her, she has to go through you. So this is kind of like it adds 1 to this you node, because this is one of the shortest paths that that has to pass through, right, this node. So the higher, right, the betweenness centrality is, the more important this node is, right? Think about the more important this node is to the network. That means this node is like very pivotal to the network, that if you want to say a lot of the shortest paths are actually have to go through this node, right, for it to like work, right? So therefore, if you really want to spread some news in this, think of it as a social media network, right? So you want to start with these like almost like influencers, right? Like you is kind of like the influencer, therefore it has like very high betweenness centrality, and then you start with like several like key nodes or key influencers, and everything, the news will spread across the network very fast. So that's kind of like the idea of like this, right? And then the degree, right? G dot degree is like to tell you the number of edges adjacent to the node, right? So let's look at the degree, right? So if you look at just degree, and then you can actually see for Alice is 4, that U is actually 5, right? Is the highest. So you can conclude from here that U is actually the influencer in this, in this network, which makes sense, right? Because you're connecting all these nodes through you, right? So Alice, mom and fiance are connected through you. So therefore you have the highest degree, you have like the highest betweenness centrality. So, here it says like the hubs in the path. So shortest path, you can actually we can look at the shortest path in here. So, right, so networks like NX dot, right, shortest path in here, right? So then you're passing G, our network inside. You can see, right, the shortest path, let's just look at the shortest path alone, right? Okay, so this is saying, okay, for Aunt Alice, right, and then Aunt Alice to herself, it's just, that, and then fiance, and then for fiance, Aunt Alice, you, fiance, right? So like, you kind of have to go through you to get to Aunt Alice, and so forth, right? So this is to tell you the shortest path, all of the shortest paths in the network. So that's pretty much the summary of how you can create a network and how you can mine a network using all these embedded function in network X. And also, if you have a text file, you can import the text file directly through into a network like this, right? So if you have some saved relationships between many nodes, you can just import it into a class object of network X, right? Networks, and then do the analysis on the networks. So thank you.